To understand a lot of the problems for math, we're going to need the numbers. Some of the problems that you see as you get into higher math are going to ask you about irrational, irrational, also imaginary or complex numbers. So that's why we need to understand the basic numbers first before we move on to the next portion. The main group of numbers is the real numbers. And real numbers are going to be any number that can be written as a decimal, and the set of real numbers contains other subsets. So real numbers are a big group that has little groups inside of it. So the set of real numbers has the natural numbers, it has whole numbers, integers, rational numbers, and irrational numbers. As you move into higher math, we don't really care about whole numbers, but the other sets are going to be coming up, and you need to know when to use it and figure out what they're asking you. Natural numbers are going to be the counting numbers. So 0 is not included. We start with 1, 2, 3. There's no decimals, and this set never ends. The whole numbers are a slightly larger set. It's a slightly larger group because it is the natural numbers, but we're only adding 0 to it. Natural numbers are positive numbers. In this case, we say that whole numbers are non-negative. So anything that is non-negative, and it has to be like your counting numbers. The next group is integers, and integers are going to be the numbers that have no decimal. There's also not a fractional part, and this includes negative and positive numbers, and you need to add 0 in between. So it could be -3, -2, -1. It could also be positive 100 or 1,000 or 1,700. So anything that is a whole number, it could be either positive or negative. Rational numbers are numbers that can be written as a fraction. So the quotient A or B, and we say that A or B have to be integers. And you cannot have 0 as a denominator. So any type of decimal that either ends or it repeats is going to be considered a rational number. In the examples that we have right here, if you have -3 is a integer, but at the same time, it's also a rational number because you can also put -3/1, that is a fraction. This one, -4/2, -4/2 is the same thing as saying -2. That is going to be a rational number. If we have -1.5, that's going to be rational. You can have -1, 0. But now in the decimals is where some people get a little confused. But if we look at the first decimal that we have right here, we have 0.32, 32, and then you see the 3 again. So this is going to be a repeating decimal. So because it's repeating, we say that this is also going to be rational. And the last one that we have is 2.77. Again, that's going to be a rational number. Irrational numbers are going to be numbers that we cannot write it as a fraction. It cannot be the quotient of two integers. And the example that we have in this case is it could be a negative, so the negative square root of 31, negative pi, also the number e, the square root of 7. We also have the cube root of 12 or 5 pi. These are products of rationals and irrational numbers, so that's still going to be considered irrational. You have to be careful because not because something is in the square root automatically makes it irrational. For example, if you get the square root of 4, the square root of 4 is actually 2, so that's going to be a rational number and not irrational. So the fact that you see a square root, don't assume it's going to be irrational. When it comes to the operation with rational and irrational numbers, the sum and difference of rational numbers is always irrational. So anytime that you add or you subtract two rational numbers, your answer will always be rational. For example, if you have 4 and another rational number is going to be 1/2, so we subtract 1/2 from 4, we know that this is going to be 3.5. Let's say you have the square root of 9 plus 2. The square root of 9 is 3. 3 plus 2, that's going to give us 5. So our answer, once again, it's a rational number. Now, when you add or subtract numbers that are irrational, most of the time those numbers will be irrational. There are some few cases where that doesn't happen. So, for example, if you have the square root of 2 plus 1, we cannot really do anything to simplify this. We're going to get the square root of 2 that is an irrational number, and that's going to keep going forever. So we will get something like 2.4142135, and this decimal keeps going forever. So this is not going to be a repeating decimal. It is not going to be a terminating decimal. So this is going to be an irrational answer. If you get another number, for example, pi plus pi, that's just going to give you 2 pi, but that's still going to be an irrational answer. So most of the time that you add or subtract numbers, they are irrational. Even if the other one is rational, you're going to get an irrational answer. Now, we do need to see a case where that doesn't happen. So I'm going to give you two cases where when you add two numbers, that doesn't happen. So if you have the square root of 2 minus the square root of 2, the square root of 2 minus the square root of 2 is 0. And 0 is going to be a rational number. So in those cases, it won't work. That's why at the end of the sentence it says, unless the numbers are additive inverses of each other. So if they're opposite of each other and you combine them, you're going to get a rational answer. Other than that, that's not going to be the case. So that happens with a square with the square root of 2. That would also happen if you have pi minus pi. That will give you 0. So if they're opposite of each other, they're going to give you 0. So that means that it's not going to be an irrational answer. Whenever you are multiplying, the product of two rational numbers is always rational. That's not a question. If you multiply, for example, 2 times 1/2, that's going to give you 1. That is going to be a rational number. You can also multiply 3 times the square root of 4. The square root of 4 is 2, so this is going to give me 6. So those are examples that it doesn't matter what you're getting at the end of the problem. If the two numbers that you're multiplying are rational, you're always going to get a rational answer. Now, when it comes to irrational numbers, that is not always the case, and you have to be careful with that. if you multiply some rational numbers, for example, if we go with the square root of 3, and you multiply the square root of 3 times 2, this is going to give you 2 square root of 3, and if you put that in the calculator, you're going to get that this is going to be a number that doesn't repeat, it doesn't end, so this is going to be an irrational answer. The same thing, it will happen if you were to multiply 4 times pi. You get 4 pi. So this is still going to be an irrational answer. But in some cases, you're going to get a rational answer. For example, if you were to multiply the square root of 3 times the square root of 3, when you multiply the square root of 3 times the square root of 3, this gives you the square root of 9. And now the square root of 9 is actually 3. So in this case, that's going to be a rational number. So in those cases, that's going to be a rational number. I'm going to make another example that is slightly different. Let's say you have 2 times the square root of 5 times the square root of 5. This is going to be 2 times the square root of 25. The square root of 25 is 5, so the answer for this one is 10. So in this case, on the right hand side, you are getting rational numbers. So whenever you're multiplying irrational and rational numbers, you may actually get a rational solution. So you have to be careful in those problems.